Hey guys, so the like metaphorical bell went, so I just want to finish explaining this for a second. Stepping back from it for a minute, we can't forget that g of x has an asymptote. So that's why the domain looks a little bit strange, actually. So one of the things that we need to think about is the fact that here, just tracing it down, we can see that at 2.002 there's a point of intersection, but actually at 2 there is an asymptote for g of x, which means that actually the space where they are, where the domain is, and I'm just going to move this over, is actually, it's only between 2 and 2.002. The other part of that is that way down the line, and I mean, if I zoom all the way out until we have an x value of 2045, at some point those are going to cross back over, okay? And that's where the other piece of the domain is. So from 2045.996 to infinity is also where f of x will be greater than g of x. In other words, the blue line will switch places with the red line. So I'm going to write that out on the whiteboard screen, and that way you can see as well what we mean mathematically by those domains. But just to refresh, just to recap, if I go back here and I zoom way in, I can't forget here that g of x is restricted by its asymptote at 2, and therefore zooming way in, there's only a very small region between, because the graph doesn't exist, g of x doesn't actually even exist less than 2. So the only place where f of x can be greater than g of x is in this tiny sliver between 2 and 2.002, where they both exist even as a graph at all. And because after 2, g of x becomes absolutely irrelevant, and we can't talk about it when we're talking about comparing the two of them because it doesn't exist to the left of 2 in the first place. I hope that clarifies. I will see you guys all later.